Before we begin to address systems engineering, that is, the engineering of a system, we need to have a brief look at what we mean when we say that something is a system. Now, this is particularly important because the word system is perhaps one of the most overused words in the English language. And that's because the word system has many contexts. There are physical systems such as solar systems, river systems, railway systems, satellite systems, communication systems, information systems, pulley systems, nervous systems, just to name a few. And then there are conceptual systems, such as philosophical systems, social systems, religious systems, gambling systems, banking systems, systems of government, and many, many more. The word is even used for more esoteric examples, such as the consideration of individual and social behaviour as a system of purposeful events. Now, in all these contexts, the common aspect of the use of the word system comes from its early meaning and its Greek root. A system refers to the whole, or the set, that results when a number of things have been grouped together, in a particular manner and for a particular reason. What the set is, how it's grouped, and for what reason, is context dependent, however. So before we continue, we should briefly consider what we mean by a system in the particular context of systems engineering. In systems engineering, a system can be defined as a set of elements that interact to achieve a stated purpose. This definition implies that a system comprises system elements with interconnections or interactions between those elements, and by the very act of identifying the system that we're interested in, an external system boundary is also implied. When we draw the boundary around selected system elements, we define the system of interest. That system of interest comprises those system elements and their interconnections that exist within our defined system boundary. The purpose of the system is called its mission, which must be clearly stated by business management and stakeholders. The mission represents the start point for the design process, as well as providing the basis for the ultimate test of the system's fitness for purpose once it's been fielded. In the broadest sense, then, the mission of the system is to provide a solution to a business problem. This narrowing of the general use of the word system is very important because it has two major implications. First, when we refer to a system as comprising system elements that are interconnected in order to achieve a purpose, we imply that all three of those principal aspects result from conscious choice. That is, we're referring to a system that has been deliberately designed or engineered, hence our interest in systems engineering. A system that has been engineered to perform a specified mission must be able to perform that mission with relative autonomy. That is, it must be managerially and operationally independent, and it may well have even been procured independently. We return to this issue shortly when we discuss the difference between systems and subsystems and between systems and systems of systems. There are numerous ways to classify systems. Here we identify the four main types in order to be clear as to which type of system we refer to in systems engineering, and therefore in the remainder of this course. There are closed or open systems. There are natural, human-made or human-modified systems. There are physical or conceptual systems. There are precedented or unprecedented systems. Let's look at each of those a little more closely. An open system interacts with its operating environment. That is, it's open. It accepts inputs from that environment across its boundary and returns outputs across the same boundary back into its external environment. A closed system, on the other hand, is isolated from its external environment. We are only interested in useful systems, which must therefore be open. Natural systems contain natural elements and are the result of natural processes. Human-made systems come into existence through the efforts of humans and may contain some human-made elements or perhaps some natural elements adapted to human-designed purposes. Natural systems that have been modified for human purposes are called human-modified systems. The systems engineering for natural systems has certainly not been conducted by humans, so we are only interested in human-made or human-modified systems. Physical systems exist in a physical form. Conceptual systems do not, they're conceptual. Since our focus in systems engineering is on engineering a system, things we can actually produce, we're interested in physical systems. In a precedented system, similar such systems, or at least the majority of system elements, have been produced before. An unprecedented system is one that's not been previously produced. Systems that comprise mostly unprecedented elements are the result of research and development. Here we're focusing on systems that comprise largely precedented elements, that is, those that we have engineered before, and therefore those to which system engineering is most appropriate. Now, based on those four classes of system, there are a wide variety of combinations that can lead to a large number of types of systems, each of which has markedly different properties. But it's important to recognise that in this course and in systems engineering, we're talking about open, physical systems that are human-made or modified from largely precedented elements. Now, returning to our simple diagram of a system. Since we're interested in engineering physical systems that are open, our system of interest must accommodate external interfaces, that is, inputs and outputs, across the system boundary, connected then to external elements that exist in an external operating environment or perhaps a related system. To extend even further, sometimes we need to be aware of an even wider context. So an SOI might be considered as part of a wider SOI, a WSOI, which exists within an operating environment. And that operating environment could be conceived to even be part of a wider environment. In a physical sense, the term system is sometimes considered to be synonymous with product. That is, we say that the project is delivering a system or it's delivering a product. A system, however, is normally considered to comprise a number of products. NCEIA 632 sees a system as comprising operational products, or end products, and enabling products, such as test, training, and disposal products.